Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
Today we are speaking with Daniel Vogelnest, who is the founder of Ninox Robotics, who are leaders in drone and robotics technology. So 10 years ago, I would have thought some of the things we're doing today is almost science fiction. And you don't need to just listen to this to understand the pace of improvement in drone technology. Not long ago, drones used by recreational users were huge and expensive, and years later they fit in a small little backpack and are affordable to everyone. Ninox, however, are using it for commercial uses, and they are using some of the top drone technology in the world. So in the show we talk about the capabilities of drones and what the range, speed and real-time data they can provide. What type of information does the drone provide the user? And what are some of the top commercial uses for drones and some case studies from Ninox Robotics? I hope you guys enjoyed the show. It was great speaking to Daniel. Without any further ado, here he is.
Sure. Well, I guess it started off at university. I studied mechatronic engineering at Sydney Uni, and obviously there I, was enjoying my time playing with robots and all of that. And I always kind of knew that I wanted to start a company. I didn't really know what I wanted to do or anything like that. Eventually, after a short stint in IT, I decided that I needed to do something that would help Australia. And my business partner and I met, and we were brainstorming about what we could do if we were going to start a company. And we figured drones and agriculture were going to be a really good combo to start with. And obviously it still is a great industry to be in, agriculture, but we quickly realized that drones could be applicable to pretty much any industry where there's a large areas involved, and that's where we went.
Yeah, awesome. So can you just tell us a little bit about the company Ninox Robotics and what you guys are up to at the moment?
Sure. So Ninox Robotics, we are a drone service provider. We specialize in providing services to larger organizations and businesses, specifically for beyond visual line of sight flight, which is something that not many other companies are doing, especially in Australia, or one of very few. And the reason for that is that the regulations are prohibitive. So it's quite hard for any particular company to just go, all right, I'm going to fly 20 kilometers in this direction. You need a lot of certification and approvals to do such a thing. But there's some really key benefits you get out of doing that, and that's why we do it as a service.
Yeah, awesome. So when was the first time you saw drones, and how is the technology developing, and how rapid is this development you're seeing?
Well, I'm sure, same as everyone else, like we would have seen the quadcopters start up, and obviously they've gone crazy there. Yep. It's amazing what you can get in a hobby quadcopter these days. For a couple of grand, you can get some amazing technology. And that industry has been booming because it's a commercial product and everyone can get it, and there's a lot more people involved with that. The drones that we deal with for beyond visual line of sight flight, there's a really big benefit in using fixed wing platforms.
So what was that you said? So beyond sight of... Say that again.
Beyond visual line of sight. Sorry, is it breaking up at all? Or?
Oh, no. So what actually is that? Does that mean? Can you just break it down?
So beyond visual line of sight is the term that CASA, the Civil Aviation Safety Authority, use to talk about flight where a UAV is being controlled out of the line of sight of the operator. So you've got someone on the ground with the controls, like normally with a quadcopter or whatever, they're manually, they've got the thumbsticks and they're flying it via video, or they're watching it just fly around them. But in our case, we've got a computer at the ground control station which has a video feed from the drone and a map which shows where the drone is. And usually we'll be many kilometers away from where the operator is. So, and you lose sight of the thing very quickly. It's quite stealthy, awesome. Especially if you're flying high. So that's really where there's a gap in the two sections of the industry. You got the small drones and the big drones, and as soon as you get out of line of sight, it's a whole different category.
So I'd imagine it's not someone sitting there with a remote control. It's pre-programmed the routes it's taking. Is that right?
Yeah. So it depends on what we do. So the main two categories that we operate with is real-time video streaming and mapping or surveying. So in the video streaming category, it's usually in response to an emergency situation or a real-time event that we need to cover, and you often don't have the time to pre-plan that. In that case, the operator can put waypoints in on the map, and the drone will fly to those points and circle, whatever.
And what kind of event would that be? Like, say, like a bushfire or a flood or something like that?
We do a lot of emergency response for fire management and floods, but also storms, looking for storm damage or search and rescue for people, or the search part of that at least. Any kind of situation where you need spatial awareness. Like if you need video of what's going on the ground, that's where we come in very handy.
Awesome. And the other one you said there was mapping and surveying. So can we just tell us a little bit about, I guess, the comms range and the scale, and maybe the some of the detail you might get from your version of surveying compared to just getting a few blokes going out to site and strolling around with I don't know how they used to do it, but
compared to typical ground-based methods, obviously you can cover a lot more ground. If you compare it to the smaller quadcopters, same thing. You cover a lot more ground. The accuracy and the resolution is often pretty similar because we will fly higher to get more coverage, but we have better cameras because we can carry more. The process is we'll say it's a road or a pipeline, any kind of linear construction. We'll just fly a line and take multiple photos as we go and do the same as we come back. And we make sure that there's a bit of overlap, quite a bit of overlap between the images. So when we actually process all the images, it gets the elevation data out of those images, and we can actually tell where, if you compare two different dates, you can see where construction has actually occurred. You can see where ground has been filled in or dug up, or often of interest is when there's subsidence. So if for a pipeline, especially if the ground has dropped over time, it's an issue for them. They've got to make sure that doesn't happen, because it means the pipeline could be moving and causing damage and things like that. So normally doing that by ground is quite tedious and time consuming, whereas via air, it's much quicker and you get a lot more data out of it.
Unreal. Yeah. And what kind of accuracy for, say, one elevation, what kind of accuracy could you get in terms of like the elevation of the construction or anything like that? Sure.
It's often a hard one to quantify because it does depend on the exact conditions. So if we're flying, say we're flying at near our lows, say we're flying at 200 meters above ground level. And just to clarify, that's another thing that we do differently to most operators, and we need special approvals to do that. So for anyone listening, don't go out and fly that. Make sure you stick to NASA's rules.
Yeah. I don't know if you heard about the guy who went and got the Bunnings sausage. You probably heard about that, did you?
Oh, yeah. Yeah, we heard about that.
It's no cowboys.
Yes, no, there are certainly some dangers out there, and it's good to stick to the rules, especially as a business, or anyone, if we're flying at 200 meters above ground level, the kind of accuracy that we could expect, it also depends on the resolution of the imagery. So say we're using a narrow lens, which will give us higher resolution but a narrower field of view. If we're getting 2 centimeters per pixel in the imagery. So for each pixel represents 2 centimeters on the ground. Then we can expect an accuracy of around 2 to 3 times that. So 4 to 6 centimeters, and that's
unbelievable.
The global, like the positional accuracy. So each pixel will be around 4 centimeters off where it actually is in the world.
Yeah.
And for vertical accuracy, it's a little bit worse. Maybe like three times. So it'll be 6 centimeters or so off the vertical. And trying to spot those differences in elevation is like, even with that error, it's quite easy if you use some visualization tools to look at that. Like, you'll have all this noise where because of that error, there'll be a bit of up and down in spots, but there will always be an obvious trend of where the ground is dropping over time or stuff like that. So yeah, it's amazing what you can pick up.
Amazing. So you mentioned a couple of uses. Is there any, what uses is it actually being used for right now, and what ones kind of uses do you think it's not being fully utilized yet for?
To be honest, I don't think it's being utilized fully, like in almost every industry.
Sounds like it, yes.
Yeah, so there's obviously a lot of benefit to this, and I think it's just going to be a matter of time for people to realize the amount of data you can get out of it, and not just that, like the actionable data you get out of it. And that's the key thing that we're always trying to convince clients, is that if you use our services, it's not just some photos you're getting. Like, if an accident happens 6 months down the track and you need to figure out what happened, so you can prevent it from happening again, you'll have, if you're doing monthly flights, you'll have 6 flights where you can see the issue progressing, and then you can go back for a whole bunch of different areas and find those same mistakes. Whereas, most people aren't doing that. It requires a bit of effort, but the payoffs are enormous, especially for like big construction and big, or any kind of work that involves a lot of money. Like those things cost a lot. Yeah,
I know. At my old company, when they were looking to do a new infrastructure job, I wasn't in infrastructure myself, but they'd just go on this huge road trip to look at the area and get a feel for it. And it just sounds like it's crazy. Something like you guys could probably do it in a couple of days and probably get better data than a few people just off on the car for 3 or 4 days.
Yeah, that's exactly right.
Yeah. So how does it integrate yet with things like Revit or BIM, or I don't know what big infrastructure programs might be used, but can it integrate with programs on the computer to be able to aid people in their design also?
Yes. So a lot of the data that we get is in very standard formats. So you can import it into any kind of geospatial software, like any GIS software, or engineering modeling software, things like that. I mean, even at its most basic form, it's just, you can just import it as an image. We can represent everything as an image. So as long as you can upload an image to the system, it'll work. But I mean, most of these softwares have everything much more advanced than that. So, and even if you don't have any software, there's some great like cloud processing platforms out there these days, so you can just visualize everything on the web. And we have quite a lot of companies coming to us that are using those kind of technologies where they don't actually have to build up their infrastructure at all. Yeah, there's a lot of options out there, and we're happy to help.
And is the technology combining? Do you envisage it combining with other technologies like artificial intelligence or virtual reality, and this to getting some incredible kind of offering that you guys no one can offer at the moment, I guess?
Definitely. So artificial intelligence is a big one. That's what I want to see develop more in the industry. At the moment, there is some work being done for certain industries. Recently, I went to a conference for forestry, and I was quite impressed with, it was quite a small conference, and I was quite impressed with the amount of work they've gone to in developing some artificial intelligence and machine learning algorithms to automatically detect trees count the trees, detect the heights of these trees, and all of these things. So, it's definitely possible.
So would that the use there be understand when the tree's ready to, I guess, be harvested or used for the wood and all that kind of information for them?
Exactly. So they need to know how much wood they're getting. They've got to estimate that, and they've got to they're just going to monitor the situation over time. And when you've got a huge amount of trees, that's pretty hard to do. So using drones and other aerial imagery, even satellite imagery, they were combining all of those techniques, which I thought was a very good move. Like, I don't see that enough either.
Amazing. And do you see, say, this is, I guess, the biggest scale where you're doing from very high above to get information. Do you think in the future we'll be at the stage where real time you can monitor, say, a building site as well, like a construction building going up, and you can see almost, the drone understanding every piece of reinforcement being installed and all this kind of information? Do you envisage something like this happening also?
Yeah. Well, it depends. Like, it depends on which technology develops faster. I think if artificial intelligence develops quicker than the camera technology and the battery technology and all of that, I mean, we won't need to be doing that. It'll be done automatically, and we'll just get alerts when something's going wrong, which is the key thing that you'd want. You just want someone doing the tedious work, an algorithm, and we'll get notified to actually do anything. But if it's the other way around, and we have, I mean, even with today's technology, we can fly 24/7 over an area. We'll just put up a new drone when the batteries get low and keep constant eyes on the area. But it depends on what you need. You have to have that need for that. And at the moment, it's probably not as cost effective as other methods.
Yeah, phenomenal.
But it'll get there.
Yeah, awesome. So what do you think will have the biggest impact on the buildings industry or construction industry in the future, including infrastructure?
That's a good question. I do probably think artificial intelligence combining all of these technologies will be a big thing. So a lot of people are, just constantly monitoring things, and it's a lot of tedious work that could be automated. And for those that aren't even doing that, I mean, it'll be great if this just comes along this software that uses drone imagery and all of the other sensors that people are using and provides a solution there. I think that's going to be a really beneficial thing for every industry, and I don't think it's that far off.
Yeah. Everyone's saying decades away, but what do you think? Not so far. Well, five.
Well, years? I mean, it depends what you mean by AI. So, I mean, a lot of people, when I say AI, they're thinking something that's conscious and can talk to you and all of that. I'm more talking about machine vision and machine learning, which is just kind of dumb AI. It just has a task. It'll monitor drone imagery to spot something going wrong in the construction or something like that, and just providing those alerts. And that's, I mean, it's already, the technology is there. There's lots of things popping up, and it just needs some people to actually start some companies and push out that software.
Yeah, phenomenal. That's it. Awesome. Yeah. Thank you so much, Daniel. Is it where can people find you if they want to learn more about what you guys do, or if get some drones to survey some of their sites?
It's pretty easy. We have a website, ninox-robotics.com. You can call our number 1300 377 977, or email us too. I mean, it's all on the website. We're easy to find. Just Google.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future. Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes so more people can hear from the people who are making our cities better places for our future.